Here we have a SAT math question. Okay, let's go with the information. Ne equals to 4 times NF times NM divided by NF positive NM. Evolutionary biologists measure a species' effective population Ne to assess its health and evolutionary patterns. The formula above relates Ne to NF, the number of females capable of breeding, and NM, the number of males capable of breeding. Which of the following express the number of females capable of breeding in terms of the effective population and the number of males capable of breeding? So this Ne represents the effective population of the species, and this NF represents the number of females capable of breeding, and this NM represents the number of males capable of breeding. So according to the question, we have to find the number of females capable of breeding in terms of the other two quantities, Ne and Nm. So we have to solve for NF in terms of Nm and Ne. Okay, now let me assign some new variables for these two quantities, Ne, NF and Nm. So that is let E equals to Ne and F is equal to NF and M is equal to Nm. So I assign these new variables to make the solving process easier. So now this Ne can be replaced by this E. So then this 4 times this NF can be replaced by F and Nm can be replaced by M. Then we get F positive M. Okay, now in this equation, I have to solve for F because F represents NF, that is number of females capable of breeding. Okay, now to solve for F, first let me get up this denominator F positive M. For that, I have to multiply both sides of this equation by F positive M. Let me do it, F positive M. So this F positive M will cancel out. Now I have to distribute this E to this F and M. So when I distribute this E to this F, it will become EF positive. When I distribute this E to this M, it will become EM equals to 4Fm. Since my aim is to solve for F, I have to get the terms which contain F on one side of the equation. So, but here the term contains F over here on the left side, and the term contains F over here on the right side. So, since I have to get the terms which contain F on one side of the equation, so let me get rid of this term on the left side. For that, I have to subtract EF from both sides. Let me do it. So, when I do so, this positive EF, negative F will cancel out. I'm getting EM is equal to 4Fm negative EF. Let me write the same equation over here. That is EM equals to 4Fm negative EF. Okay, so my aim is to solve for F. And here, these two terms have the greatest common divisor F. So we can factor F out. If I factor F out, then I have 4M negative E inside the parenthesis. Okay, since my aim is to solve for F, I have to get rid of this 4M negative E, which is multiplied by F. So let me divide both sides by 4M negative E. Let me finish my working. So this 4M negative E will cancel. So finally I'm getting EM over 4M negative E equals to F. Okay, I've solved for F. Now we can replace this E, M, F by the original stuff. So E has to be replaced by Ne. Let me do it. And this M has to be replaced by Nm divided by, so 4 times M, that is 4 times Nm negative Ne, and this F has to be replaced by NF. So according to the question, we have to solve for number of females capable of breeding. Okay, I just solved for number of females capable of breeding in terms of Ne. Ne represents the effective population, and in terms of the number of males capable of breeding, that is Nm. Okay, now among the given options, I find this stuff in option B, that is NF equals to Ne times Nm over 4 times Nm negative Ne. So the correct answer choice for this question is option B.